Hello, my name is Ryan from Buster Beagle 3D, and today I'm going to be reviewing the EM Smart Super 30 Fiber Laser Marking Machine. It's a super powerful yet compact fiber laser that is a tool primarily used for marking, engraving, and cutting of metals, slate, and plastics. It packs quite a punch in such a small form factor. So what do I think of it? And is it the fiber laser you've been looking for? Well, let's find out. I first wanted to thank EM Smart for providing me with this machine for my honest review. There are affiliate links in the video description that do help out the channel if you decide to use them, but they did not sway my opinion on the machine one way or the other. With that out of the way, let's get started. So the first thing that I wanted to do before I got into the specs of this machine, I thought I might give you a little rundown of the offerings from this company to somewhat demystify what are the differences and why you would potentially want to go with one over the other. I know it can be a little confusing when you see two machines that are the same power but wildly different prices, so hopefully this quick rundown helps. Their first offering are their EM Smart Basic lines. The only difference between the two is the wattage of 20 watt for the basic 1 and 25 watts for the basic 2. When you see the 1R and 2R, that means that it's the version that you would need if you wanted the rotary. Up next is their EM Smart 1 and Nova machines. Again, the difference here between the two are the wattage. The 1 is 20 watts and the Nova is 25 watts. Now the big difference in both of these to the basic line are that these are foldable where the gantry can easily fold down when not in use to save space. But that also limits the size of an object you can mark on. On the basic machine, you could potentially unscrew the tower and rotate it 180 degrees and mark off of the platform. On the 1 and Nova models, you are limited to the gantry height when you are using it. These also come in rotary compatible versions. Up next, there are the EM Smart MP lines. These are their MOPA lasers. If you had just watched one of my last videos, you may know that adds a new functionality to the laser called pulse width that makes this type of laser particularly useful for things like colors on stainless steel and titanium, as well as multiple different types of materials and plastics. It also has a different laser source altogether from the other machines, which is the JPT laser with a much higher frequency range of 1 to 4,000 kilohertz. The other machines all use a max laser source and a 20 to 60 watt frequency range. They come in 20 to 60 watt power input range as well. Up next is the laser that I will be reviewing in this video, and that is the EM Smart Super line. It comes in the 30 watt, which is what I have, and a 50 watt. These machines are really almost identical to the basic line except for the higher power output of the 30 and 50 watts versus the 20 and 25 watts of the basic machines. Next, we have the EM Smart PC line. These fiber lasers are very similar to the 1 and Nova lines with the same form factor and foldable design, but the big difference here is that they come with a mini PC inside to control the machine. You don't need a separate machine attached to run the software for the laser. It comes with a monitor as well as a wireless keyboard and mouse. The only other difference from what I can tell is that you cannot use a rotary with this model, as they're probably using the space in there for the PC rather than the driver for the rotary. Finally, there is the EM Smart Pro line. Again, very similar to the 1 and Nova machines as far as specs, with two notable differences. First is that the machine comes with an auto-focusing feature that lifts the platform to the proper height needed to use the machine. The other is that this version is not compatible with a rotary. That is really the only difference that I can see. So hopefully you have a better understanding of the differences between the models now, so I will dive deeper into this model that I have, which again is the EM Smart Super 30 watt fiber laser machine. The fiber laser is a type of machine that works in the 1064 nanometer infrared wavelength. That means it's specifically useful on metals, plastics, rocks, leather, and coated wood. This machine comes in a very compact form factor, which makes it super easy to use and store when you don't need to use it. It's an all-in-one unit, which might be a little bit different than other fiber lasers that you have seen in the past, with a separate computer tower and a metal plate with an adjustable platform holding the laser head. Even compared to the last review of the fiber laser, you can see the size difference. Now, I know that these two are not the same power and the other one was a MOPA laser, but even the 30-watt non-MOPA machine comes in the same form factor from this other company, so it's still a pretty stark difference. The EM Smart Super was very easy to assemble with all of the bags as well as the connection points clearly marked where everything needed to be attached. The machine also came with a pair of safety glasses that you should wear anytime you are using the machine to protect your eyes. These glasses are not branded and have no safety information as far as I can see on them to let me know their wavelength rating, but they seem okay. They also seem to be different than the ones that the company sells on their website, which do list the specs, so take that for whatever it's worth. The machine also comes with a nice material pack with lots of different things that you can test the machine on for practice and to see how this machine performs. I will be testing most of the items in this review. The laser head sits on a tower that is raised up and down by a hand crank at the top of the tower. It all runs on a pretty thick threaded rod and does a good job for the up and down travel of the laser. This machine came with a 110mm lens installed, which means you have a workable area of roughly 110 by 110mm. This lens is swappable, so you can purchase other sizes from the company, all the way down to a 70mm by 70mm, and all the way up to a 175mm by 175mm. The lens determines the workable area, so that is how you choose which one you want to use. However, do keep in mind that the smaller the lens, the smaller the workable area, but the more concentrated the output of the laser will be. The EM Smart Super is again what is called a galvo laser, which means that the laser head does not move, but tiny mirrors inside the laser head do. This gives the fiber laser an incredible speed all the way up to 10,000 millimeters per second. On the front of the machine is just a simple on and off switch, as well as an emergency stop button for shutting the machine down quickly. On the surface of the machine is a work plate with threaded holes to hold down the working brackets that come with this machine. The machine comes with two styles of brackets, including the regular right angle brackets, as well as another one that can be positioned on its side to hold round objects and keep them from rolling away. This machine can be controlled either with the included EasyCAD software or with Lightburn. Lightburn is a paid program where you will need to purchase the Galvo license, but since it is my software package of choice, it is what I will be using for all of my tests with this machine. Now, there are instructions that come with the laser for setting up Lightburn with this laser, but I felt that it may have been missing a few things, so I wanted to quickly go over that setup just to have you up and running with this machine. The first thing you need to get is Lightburn installed, and be sure to check that box during the installation to add the EasyCAD drivers. And then this is going to open up Lightburn. Now, for me, since I've already installed many different machines in Lightburn, I go right to this screen, but if this is your first time setting this up, it'll ask you to set up a machine first. So I can get to the same thing by just clicking on devices over here, and you can see I have quite a few machines. So I'm going to click on create manually, and that is going to bring up this box. And then I'm going to scroll down to JCZ Fiber and hit next. Now in here, it is asking you if you want to import in the settings from EasyCAD to set up, things initially in Lightburn. We can get these initial settings from the USB card that comes with the machine. So I'm going to hit import EasyCAD config. I'm going to come over to, this is the USB or everything that was on the USB. I come to EasyCAD 2 with the driver. Click on that. EasyCAD Lite, click on that. And then I'm going to click on plug. And then I'm going to choose the Mark CFG 7. Hit open. And you can see it already brought over a lot of the settings that we're going to need, including ports and things like that, just to give us a head start on setting up some of this stuff. You might notice that your correction file is not listed, or it'll say missing. That's okay. The only reason I have it there is because I set up EasyCAD as well. So it was already set up with the machine, but I'm just going to click next. I'm going to change this to EM Smart 30 watt, call it demo. And then what are the dimensions of the work area? For right now, since we're doing the 110 millimeter, I'm just going to say 110 by 110, even though this is actually not correct, and we're going to change that in a second. Hit next. And so that's it. You're done. We're just going to hit finish and then click OK. And then you're going to want to choose it if it's not already chosen from your settings there. And so here it is. We have it all set up. So the first thing that I want to do is I want to make sure that I have the proper focal height for the laser. Now, if you click on this enable red light button over here, and then you look at your laser, you should see 2 dots. The way that the focus is supposed to work is that you're supposed to raise or lower your laser gantry until those 2 dots meet. However, at least on my machine, I found that where those 2 meet by default is not the proper focal height. So what I'm going to do first is I'm going to make sure that these 2 dots meet. So I'm going to turn that right now. Okay, so that's pretty close. And so now what I'm going to do is I'm going to go back into Lightburn, and then I'm going to come over here and I'm just going to create a box. Okay, and that box is set to fill, which is fine. I'm going to set the speed to 1,000 is okay. I'm going to do max power to 75. And the frequency of 20 is okay. I'm going to leave that as a bidirectional fill and crosshatch. I'm also just going to change the scan angle to 45 so it does it at a 45-degree angle. And I'm going to click OK. So now, if I click on frame, it'll bring up this window. And if I look at my laser, we'll see that we have a box in the area where I want it to be on this stainless steel plate that I have down here. And then if I go back into Lightburn, what I want this to do is I want this to run continuous because I'm trying to see what the proper focal height is. And the way that you're going to do this is I'm going to run this file and I want it to run nonstop. And you'll know you're at the proper focal height when the sound and the brightness of the laser is at its brightest and loudest. So I'm going to click on run continuously, and then I'm going to put on my safety glasses because you always want your safety glasses on when you do this. And I'm going to click start. And then if I look back at my laser, we can see that it's running on the material, and it's not too bad right now, but it's still not super strong. So what I'm going to do is I'm going to raise and lower the gantry until I feel like it is at its strongest point. So I'm going to do that right now. So I feel like something like that is very, very strong. So I'm going to go back into Lightburn and I'm going to click stop. And now I'm going to close this. And then if I was to go back and look at the laser, it's a little bit hard to tell from this view, but those 2 dots are not right on top of each other. They're slightly offset. And so that means that my laser spot is slightly offset. Okay, so I'm going to go back into Lightburn. And then in here, I'm going to click on Edit, Device Settings. And then over here at the top where it says Rest Position X and Y, this is where you're going to move the laser head to the rest position that's coming out of the lens itself. So you can't really move the laser pointer that's on the machine itself. You're just moving the rest position of the beam that's coming out of the lens. So I've already done this, and I kind of know that it needs to be 0.5 in the X for my particular setup and 0.55 in the Y. And unfortunately, there's no way to see the update on the laser while you're moving it. That's really something that you have to hit OK. So I'm going to leave it on this screen, and I'm going to hit OK. And again, it's hard to see just from the vantage point because they were close, but they just weren't right where they needed to be. And so now this is the proper focal height for the laser. Okay. So now I'm going to come back into device settings. There's a couple other things we want to change in here. So the first thing is this correction file. And this is correcting kind of the bowing that might happen from the lens with your machine. I found that for Lightburn, I don't really need this. So I'm just going to clear this. And so that's going to change some of these settings down here. I'm also just going to set all of these settings to 1. Okay. All right. So now the next thing that I want to change is this width and height up here, but it's grayed out, and it's going to be grayed out until you click OK. So I'm going to click OK, which closes it, and then I'm going to come back here, come back to device settings, and open it. Now, the issue here is that even though that's our lens size, it's not the proper field size for the lens. So if you put 110 by 110 millimeters in here, you're not going to get an accurate representation of a box or whatever else you're trying to do. The scale is going to be off in your workpiece. And you can kind of test that by coming, in here and setting up a square. So like in this case, this is a 20 by 20 square. So actually here, why don't we just do this now? So I am going to just burn a line in here and let me frame it. When you're framing, you can hit the arrow keys to move on the device itself. So right now, I'm just clicking on arrow keys and I can move it around. But what I'm going to do is I'm going to bring it over here where you can see it. And then I'm just going to click on Start. So I clicked it a few times just so you could see what was going on. We'll close. Now, so this is supposed to be a 20 by 20 square, but if I go over there with my digital caliper, you might be able to you might have been able to see that was 23.29 millimeters. So it's not the proper size. So what I'm going to do is I'm going to come back into Lightburn, and I'm going to go back into that device settings. And instead of 110 millimeters, we want this to 123.8 in the width and 123.8 in the height as well. And then I'm going to click OK. And then without even moving this box, I'm going to leave it right where it was. I'm going to run it again. And then I'll show you the other side. And I might move it just so we can see it. But even now, you can see just with the laser that it's going to be smaller. Just going to put it over here to the sides, make it easier. And I'm going to run it. Again, I just press start a couple of times to do that. And then I'll go over there with my digital caliper again. And as you can see, it was essentially 20 millimeters, which is what it should be. And so that is how you fix the size if something looks like it's larger or smaller than it should be. All right, I'm going to go back into the device settings again. Okay, so there's a few other things that we want to change in here. The max frequency and the minimum frequency for this particular laser, since it's not one of the MOPA lasers and it's not a JPT, the max is 60 and the minimum is 20. I'm going to leave all of this the same. You can either set the red light to always be on, or you can have that red light turn off. That's really just up to you. This enable blanking and Lightburn is I'm just going to create another box. I'll put it over here. So when I go to frame that, you'll see that there is a line that connects those two objects. And it's not going to burn that line, but it's just doing a continual line without ever making a blank space in there. So I'm going to turn that off, and then I'm going to go back into Lightburn, and I'm going to enable blanking, which is that checkbox right there. And now when I go to frame, you no longer have that line connecting the two. So it just makes it a little bit easier to see what you're working on and what you're doing. Okay. And now I'm going to go back to device settings. I'm going to change this start marking to 14. Over here, I'm going to change the minimum jump delay to 500 and the max jump delay to 500. And then the laser on TC to -200 and the NTC to 200 as well. And that's it. That's all of the changes that I'm going to make to this laser. Yours might be slightly different than this, but this is what I found worked the best for my settings in Lightburn. So if you follow this, you should be ready to go pretty much right out of the gate to do some of the projects that I'm going to go over now. Okay, now with everything set up correctly, I briefly wanted to touch on one more point before I show you the results. Fiber lasers work by ablating the metal, which is essentially turning them into fine powder. This is really not something you want to be breathing into your lungs. EM Smart does sell an enclosure for this machine with safety glass, as well as an air purifying unit to help remove those particles thrown up in the air while using the machine. I do not have those, so what I'm using is a box that I've now used on 3 different machines, which consists of a closable door with a front fan blowing the particles to the very large exhaust duct with a powerful inline fan that provides a lot of suction to pull the particles out of the work area to a filter outdoors. I also have 2 cameras set up in the box to be able to see my work in progress, as well as film these reviews. I also have a fin plate to keep my surface clean and unmarked. I can also close the hole in the side or use it for a rotary pass-through hole. I just wanted to explain what you were seeing when I showed my laser working. I also have a link to my box in the video description if you have a diode laser and want to make your own. The first thing that I made on this machine was to try out some of those metal business cards that came in the material pack. I'm also going to do a little something different in this review where I just simply show you the settings on the screen instead of calling them out to you, so you can try to use the same settings if you want to try this. The little baby Yoda card came out very nice. It took me a few little image adjustment tests to really dial in the power settings, but overall I'm happy with the way that it turned out. Since this machine is also 30 watts, I wanted to test out its ability to cut metal business cards as well. I have used this design before that I bought off of Etsy, so I ran it again on this machine. I was able to cleanly cut this eagle from the card. It was intentionally not cut the entire way so that I would be able to use the rest of the card as a stand. Up next was a metal coaster that came in the material pack. It seemed to be an anodized aluminum, so I ran this Marvel calendar that came on the USB card with the machine. There are quite a few designs that they give you to try out, so this is just the one that I saw and wanted to try. It came out very nice and I was quite happy with it. Next, on to stainless steel. The machine came with this flask that I wanted to engrave this image I found for free on the Imager website. I first laid down a layer of white to give it a base, and then engraved dark black onto the surface. It really has a nice 3D effect that worked well with this flask. I know I could have gone with more of a black Z mark, but that effect is a little harder to do with this curved type of surface since it's so dependent on the height of the laser focus to get those black marks. There was also a little white-coated thermos bottle that came with the machine, so I pulled out the brackets that came in the box and added my logo to the side of the bottle. It worked just as I would have expected it to, and I was happy with the results. I'm honestly not sure what you would use this small vacuum sealed bottle for, but it was cool either way, and I'm sure I'll use it for something. After that, the machine also came with a slate coaster that I engraved the image of this bear onto that I also found on that Imager site. It turned out okay, but I really wasn't super happy with how I prepared the image or how I engraved it, so I sanded the image off and based on some posts I read on Facebook, decided to first spray the surface with a clear coat. In my case, it was what I had, which is this Rust-Oleum triple thick glaze, which makes the surface super glossy and wet looking. I then engraved on the surface and got some really nice results. Finally, I wanted to test my favorite thing to do with fiber lasers now, and that is 3D coins. I made a design in 3D and then converted that to a height map that can be used to slice layer by layer in Lightburn. I first tried it on a coin that came in the material pack, but it didn't really get nice results with it. I have a feeling that the coin that came with the machine was only gold-plated and not brass, like I thought it was, so it really didn't get the effect that I was after. I did have some coins that I knew were all brass all the way through, so I popped that into the machine and I tried again. It came out very nice and I was very pleased with the results. I ran a sculpting pass followed by a cleanup pass. I finished it off with a very light pass with my cheap rotary tool with a brass brush on it. It really brought back the shine of the original coin without affecting the detail too much. Next, I wanted to try it again in honor of my grandfather, who was a B-17 pilot in World War II, and because of that series that just came out about the 8th Air Force, I designed another coin, this time with B-17s flying in formation on one side and the logo of the 8th Air Force on the other. It's truly amazing the amount of detail that you can get when making one of these coins. You can see the detail down to the cable from the tail to the fuselage, and even the motor detail inside of the engines. It really is an impressive job that makes using one of these machines so fun. The last thing I did a small test on and really didn't dive too far into was colors on stainless steel. While you can get colors on stainless steel, it's really not consistent, and while it can work in some instances, it's really far better to use one of the MOPA machines for the purpose. You really just don't have the range of frequencies that you would need to have a good repeatable mark on the surface. You can even see here that with the same settings on this test piece, the heat changes the color mid-block, so while it's possible, it's not something this machine is really going to excel at. So now for my overall thoughts on this machine, it truly is an impressive laser that fits a lot of power into a pretty compact space. I obviously was able to make some incredible projects with it, so the proof is really in the result. Now, for the things that I think could be improved. While you can get an enclosure with this machine, it really is something that I hope becomes standard and more prevalent. Just how I feel like I'm now seeing more laser diode machines now coming fully enclosed to help you with the smoke in your environment. You even more want to be sure you are not shooting metal dust into the air for you to breathe in. It's essential that you have, at the very least, some sort of exhaust with an inline fan sucking the dust out of your area. The second thing that I wish could be improved is the focusing system. While the laser pointers are great, sometimes you want to be very accurate in the height, especially when you want to do dark black marking or Z marking on stainless. They require you to be a certain number of millimeters out of focus to achieve that effect, and there's really isn't a good way to do that here. Even if you had a ruler to measure the height, you don't really have any good spots to measure from since most of the surfaces are rounded. I suppose you could measure from the bracket holding the laser head, or build a focusing stick to measure the distance from the lens to the part, but either way I just wish it was a little easier to be more accurate. The last just real nitpicky thing is when you turn this machine on, the fans and the electronics are on full blast whenever the machine is on. Honestly, I don't know what fan is running, but I'm guessing it's the fan on the laser source, but it would have been nice if this fan only turned on while it was in use. It's a bit loud, so I found myself turning the machine off even between jobs to keep the noise levels down. Other than that, it's a really nice machine. I wish the setup instructions for Lightburn were a little more thorough, but if you watch that part of this video, you should be good to go. I wanted to once again thank EM Smart for providing me with this machine for my honest review. Again, there are affiliate links in the video description that do help out the channel if you decide to use them, but either way, I hope you found it helpful. Thanks again for watching. If you enjoyed this video, please do hit that like button, drop a comment, and consider subscribing for more content having to do with laser engravers, 3D printing, injection molding, and all things 3D. Thanks again, stay safe, and we'll see you next time.